everyone, I'm Matteo Collina, Platformatic co-founder and CTO, and today I'm going to dig deep into Undici, the new HTTP library built by the Node Core team. So a few words about me. I am part of the Node.js Technical Steering Committee, as well as a board member of the OpenJS Foundation. Created some libraries that you might use. I spoke about them at Node Congress a few times, so you might want to check them out, both Fastify and Pino, if you like them. I worked 8 years as a consultant, then decided to do a startup, and here is Platformatic. I have a newsletter at Nodeland of Dev, YouTube channel, and so on and so forth. You can check it out. But in all of this, the important part is you are likely using my stuff, because my downloads, my modules has been downloaded 22 billion times last year, which is probably include you as well, as that you are watching this video. So yay. So let's talk a little bit about Undici. Undici is a relatively new or modern HTTP client written from scratch for Node.js. What does it mean from scratch? It means it's not based on the internal HTTP and HTTPS module, but we created it from nothing. Okay, and Undici, not of color here. Undici means 11 in Italian and comes from HTTP 1.1. And it's also a Stranger Things reference, because I was watching Stranger Things when this started to come into my mind. So how does it work? Well, it's very easy to start using, to be honest. You can just import requests from Undici and just put your URL in, and you get all the things that you would expect. You get a status code, headers, trailers, and body. You get all the things. Okay. Note that it has implement the same body mixing of fetch. So body will have, you can await body.json, for example. Okay. Something very important to remember is whenever you get a body, please consume the body. Okay. There are certain logic internally that will make sure that things are handled correctly, but clean it up, okay, if possible. Undici is also the home of fetch for Node.js, okay? When you use fetch inside Node.js, in reality, you're using fetch from Undici, and Node.js bundle Undici internally, and it's the spec-compliant fetch that you like and love, and that's more or less all of things that needs to be said. We are working very hard to have a higher spec compatibility as possible, so this should, in theory, works as close to as possible as the fetch that you are running in your browser, and also the other runtimes. So if you need to have spec compatibility, if you want to work on spec compatibility for fetch, Undici is the right place. What are the good things about Undici? Okay, first of all, Undici has improved performance. We'll go through that later. I have a cool few slides. It also creates a complete split between the API, the public API, the developer experience, and how connection management is handled. Something that was not present in HTTP.request and the HTTP and the HTTPS module. And it has also multiple pool implementation. Pool? I said pool? Yeah, I said pool. Because HTTP is a connection-based protocol, so you probably want to do connection pooling, okay? Despite all the literature says that HTTP is a stateless protocol, but it's stateless because you're talking about a stateful. How is this possible? Well, yes, of course, because it's stateless in the sense of semantics, but is implemented on top of a stateful connection, TCP. And TLS, of course. I will talk about what interceptors are and how to integrate with them. Also, it's maintained by the Node Core team, HTTP team. And in fact, most of us think the HTTP.request is almost unfixable. And therefore, that's what we are working on instead. And at the beginning, it started from support for HTTP 1.1 only. Then it became we also recently added HTTP 2 support. And now it's, the Undici name might not be the best reference anymore. Anyway, so also we have HTTP 1.1. Oh, sorry, this is, yeah. It also has HTTP 1.1 pipelining support. So it also something that is a little bit, there's some things that are different in it. So you might experience some a few errors that you might need to deal with, essentially. So why? Well, the problem is the HTTP modules are a mess, okay? Mostly because they use the same API structure for both the client and the server, okay, of HTTP1. And both of them are tied with the connection management with the public API. So how can you see it? Well, you have request.socket, okay? The fact that you have a request.socket property will tell you that there is this kind of connection. Because if your system is not based on socket anymore, like on HTTP2, how would you implement that? And this is the reason why you cannot support both HTTP 1.1 and HTTP2 on the same API. Finally, last but not least, we cannot change those classes without breaking Express. So, yeah, well, that's the situation. So, we created Undici.request to be as fast as possible. And because making HTTP requests should not be the bottleneck of your app, it also provides a good enough DX, a very good DX from my point of view. It's highly configurable. It uses Node.js Stream, supports HTTP 1.1 pipelining. Is great. Just use this. Okay, this is probably the library, the code that you want to be using. Okay, Undici Fetch is built for to be spec compliant, okay? So it's not putting performance as the top priority. It's building spec compliance. Spec compliance is. And right now, 88% of the WPT tests that we are running for Fetch, we are passing them. So I think it's pretty good compatibility overall. However, internally, it uses WhatWould streams, and so it uses WhatWould stream, so you can use pipe2, WhatWould stream, all the things, the readable stream like the browser. So all the code that uses Undici Fetch and Fetch Node could be isomorphic. Again, the protocol handling and the API are completely split. So all the things that we are going to talk about, Undici and connection management and so on, all apply to both. And this is the reason why Undici Fetch was built on top of Undici. The fetching node was built on top of Undici. It also supports HTTP2, HTTP pipelining because of this separation. Okay, let's talk about performance, because this is the critical stuff for it, okay? So, which, it's, the numbers are really significant here, okay? Like Undici is pretty much unconstrained, okay? You can use, on this testing system, you can actually use Undici, one of the lowest level API, which is Undici.dispatch, but to be honest, this is not what you should be using, okay? It's the underlining bit, or Undici.stream, which is, even, which is faster, but again, probably too lower level. You can get those up to a huge amount of requests going out from a single node process, okay? Getting 20,000, 21,000 requests per second out, it's a lot of requests that you're going to send, okay? So essentially, our goal is making HTTP requests should not be the bottleneck of your app with Undici.request. And you can see how the other APIs are being set up. So we have Super Agent, we have HTTP from Node Core, we have Axios, how Axios perform, we have our the old school request module, how that perform, down to Undici Fetch, which is actually slower. Okay, as I said, there is a lot of things can be optimized still, which just a tad bit faster than Node Fetch, which is great. And then we have got at the end. Okay, just to clarify, all of this is actually very important to note that if you are experiencing any performance problems doing HTTP requests, you probably should switch to Undici. I talked a lot about HTTP 1.1 pipelining. And I really want to explain it, okay? Because otherwise you probably won't know what I'm talking about. So in a normal HTTP request, when you open a request from a client to a server, okay? First of all, there is a ping pong, okay, of the opening of the HTTP request, okay? On top of that, you need to add TLS if there is TLS. So yeah, a lot of exchanges. Once you have this connection set up, okay, the client send one request into that socket, okay? Once the socket came back, it does the processing and get it back to the beginning. And then it can send a second request on that socket. I told a lot about connection pooling. So you have essentially, if you want to talk to another microservices in your network, you have, I don't know, 3, 4, 5, 10, 20, 50, whatever connections. So you want to, allocate one connection to a request up until you get the second, the request, the request after. So if you have 50 connection, essentially it means that can only be 50 requests in flight overall, because each one connection, one request, okay? Pipelining changes that. So with pipelining, we can send 2 requests at the same time, okay? We can send 2 requests at the same time, one after the other. Now, this is great because we can actually cut the response time significantly, because we send 2 messages and we can save all the round trip time, okay? The servers then will need to parse those one after the other and then send us back the results, okay? Which it's fine, because if you slide in this example, it takes 172 milliseconds to get both responses, while in the other one is 228. So we are actually responding sooner and having data sent back sooner. But there is one catch, okay? What happens if the first request is delayed? If the first request is delayed, okay, as you can see in this example, we are actually losing a lot of processing, okay? The second one, the shorter one, needs to wait to be sent, okay? Because first I need to send the first one and then I need to send the second one. This phenomenon is called head-of-line blocking. So, okay, so great, not great, you need to take this into account, okay? But especially when calling microservices, this is probably fine, or in my experience, this is fine. And it can help us achieve way, way, way more throughput, because we can use our sockets way better, okay? So let's take a look inside and how this works. And first of all, we have, we want to provide the foundation for HTTP next. And as I said, we separate the API from the API, the API that user use from the internals. So there are 2 separate layers, completely independent from each other. And all the internals are callback based. They're not based on errorbags, and they're not based on events. Okay, so they're based on lower level mechanism that is extremely fast. So we are not having any overhead whatsoever. Also, we manually manage a connection pool, okay, and you can do different things. And we are very picky about overhead and memory allocation. Last but not least, we minimize the transition between C++ and JavaScript. So the key part of the connection management and how you interact with the internals is by the concept of a dispatcher. And there is an API in Undici that's called set global dispatcher. So if you want to change the global dispatcher or the global mechanism for handling the HTTP request, you can do it anytime via the Undici library, calling set global dispatcher and passing either an agent or something else that we'll talk about sooner. You can configure a lot of things. You can put a lot of parameters in here, so you check it out. Now, what's important to note is that calling set global dispatcher from Undici will also change the one from fetch in Node.js, as the 2 things are built to be completely interoperable. So what is the hierarchy of those dispatchers? So we have a dispatcher abstract class, which includes a bunch of things, and it includes a lot of the fancy methods. And then we have an abstract that implements the dispatcher for connection management. And from there, we have the client, which wraps a socket, a connection, okay? Then we have the pool, and the pool, it's an array of clients, essentially. So, if the pool receives a request, it says, give me a free client. Otherwise, it waits, okay? The balance pool is an alternative pool system that uses a recent algorithm that was published on a recent paper that allows us to choose the socket that has the best, that will offer the best latency for that specific request. How does it work? Yeah, it's a complex algorithm, so check it out. It uses a lot of weights and maths to make it to do its job. What does the agent? Well, the agent allow you to work across from a client, to work to coordinate an array of a group of pools, okay? One for each origin. So if you have a combination of domain plus port or IP plus port, then the agent is the system that coordinates it and route it to send the request to the right pool. This system also allow us to implement a mock agent or a mock system for Undici, which is built in. So you can actually configure a mock agent, and the mock agent can be set up to only intercept a few requests. So if you configure this, you can intercept a request and you can route it via the mock agent. Seems fantastic, right? There's no monkey patching happening, nothing. This just works out of the box. Okay. I've thought why it's called dispatcher though. Well, because a dispatcher the important method for dispatcher is the dispatch method, and the dispatch method takes an option object which describes the request and a handler for that request. A handler is a complex object, okay, that implements a lot of callbacks for a lot of different state of the HTTP request, and if you're calling dispatcher.request, internally it will use a request handler, and stream handler, fetch handler, pipeline handler. Yeah, seems about correct, okay? And this is how we separate between the lower level interface, which is dispatch, and the higher level like request, fetch, stream, and so on and so forth. How many methods are there? Quite a lot, actually, because we need to track all the things. So we have a connect, okay? We have a non-connect, on error, on upgrade, on response started, on headers, on data, on complete, and on body sent. Yeah, pretty cool, right? Well, this system allows us to create something like a retry agent. So let's imagine that you want to retry your HTTP requests because they are failing for whatever reason. Well, the retry agent just does that, okay? It's built in, okay? So I don't need to do much. I can either configure it as a global agent or I can just call it. Works great. Internally, it uses implements a retry handler. So the retry agent, when you receive the dispatch method, create a retry handler, okay, that will that essentially wrap the previous handler and add some retry logic. Hey, that works. Okay, pretty nice, pretty neat, right? And it's handlers all the way down. And one of the options inside the for dispatcher are the dispatcher interceptor. Okay, sorry, and the dispatch interceptors essentially are just objects that has a dispatch function. That's it. Okay, which offer the same API as the dispatcher class. Okay, but an interceptor is an object that only have dispatch. The other dispatcher also have a lot of other methods in it. Okay, and for example, what I have created, it's a system to automatically issue M2M, machine-to-machine OIDC tokens for each request coming out to a certain destinations. In this example, and you can check it out, it's a separate module called Undici OIDC Interceptor. And we can, when you create an agent, you can configure your interceptors in the code. Okay, it's pretty great. It's pretty neat and pretty great from my point of view. And you can check it out in this slide on the right. You can see a big example for about what the provider does look like. It's a lot. Okay, it's a lot of code, a lot of config. But it's compatible with Auth0, for example. It's compatible for anything that is OIDC compatible and supports machine-to-machine tokens. So pretty great from my point of view. But be careful, because probably in the next release of Undici v7 we'll be changing these APIs. So we are working on something better. So hey, so from the code, the example we did at the beginning, you wonder why fetch is slow. Okay, so I took the liberty to run this benchmark. Very simple, very, to be honest, straightforward. We are issuing 100,000 fetch requests locally and get the text, and that's it. And you will be much surprised at where we are spending the time. All the time, most of the time, 50% of the time is actually spent in initializing the What2G streams, okay? Not HTTP processing, no, not anything else, only initialization. Why What2G streams are so expensive in initialization? Well, this is a long answer, and unfortunately probably worthwhile a talk on its own. But it's related to something, to the fact that they are transferable. What is that? Yeah, well, as I said, it's probably worth a talk on its own. So something that all of this means that you can use the dispatch logic also to make some magic, okay? So in fact, because of how this works, HTTP, the new HTTP RFC 9110, it has, just splits the semantics from the transports from HTTP 1 and HTTP 2.2. So basically, the wiring format is now only an implementation detail. But so basically, it means that we can implement the HTTP logic, okay, the HTTP semantics on essentially anything, which is fantastic. So so it means that we can essentially even completely unbind our system from the HTTP for transport. So, and in fact, this is the logic that we use for the market for the mocks. So, in fact, we could implement a system that does networkless HTTP. And if so, to do that, we need a way to inject an HTTP request in a node server, which is pretty nice. Okay, it's called, this module is called Light My Request, and in fact, this is built into one of the frameworks that I built called Fastify. And you can, pretty great framework, but you can take it and you can call inject in it, and this just works without opening any HTTP sockets. So what you could do is essentially implement it with Fastify, the Fastify Undici dispatcher, which is another dispatcher from Undici that completely bypass the HTTP request logic and create essentially a mesh network inside your process to route your requests to your Fastify server. It's pretty fantastic. In fact, it's what we use inside my startup. It's called Platformatic, and we help developers get rid of undifferentiating heavy lifting of building Node.js apps. In fact, we make you go very fast from A to B, and then we help you go exactly where you need to go, giving you all the tools like a very, very, very simple SUV. So all of this that I told powers the new the Platformatic runtime, which is a system to run multiple microservices inside the same box, inside the same process. And I don't know, check it out. It's there. I don't think I have time for a demo, but stay tuned, and because I will be publishing something sooner rather than later on this front. And thank you very much for watching, and bye-bye.